Hello, guys, and welcome to our class today on SPSS chi-square. When we did correlation, I explained to us that we have Pearson correlation and chi-square correlation, and I explained that Pearson is used for scale data, and this other one, chi-square, is used for ordinal data. Now, SPSS is the best for ordinal data. That's why it is packaged for social sciences. So we're going to be using SPSS to learn chi-square because it's perfect for chi-square. Remember in our last video, we learned how to do some of those data coding and all that. So that affords us what it takes to do that in SPSS. Although you can do that in Excel, but it's much more complex than you would in SPSS. So let's jump straight into it. This is a data set. By the way, this data set is from Cairns University. I really recommend you check them out. They have awesome tutorials on research analysis. Now, from here we have IDs, we have birthday, rank, gender, athlete, are you an athlete or not, height, weight, smoking, spring, scores in different courses, whether they live on campus or not, how they come to school, and sleeping time, study time, all that. So this is a data set for a school, and the actual data, and then we will be using this for our analysis. But before we do that, let me explain. Let's draw more insight into how data are in SPSS. Now, if I click here, you will notice that some of all these things change to what? Numbers. If I click it back, you'll see what is there. That just tells you that those variables are coded variables. They are coded variables. So it means that freshman was coded with 1, junior was coded with 3. Can you see that? And like that, like that, like that, like that. So that's just what it means. But let's look at it better so that we can understand better. The variables of this data set are on my desktop. So let's keep them side by side so that we can make some comparisons. Now here, as I said, this from Cairns University. Day is their birthday. Let's go to variable view. Now this is a variable view. Enroll date, um, rank, see rank here. Enroll date, that one is much lower here, and data is this 22 and 21 here. Major, um, gender, male or female. Now let's look at rank. I see that rank is an ordinal data. Why is it an ordinal data? Because freshman is a first year student in, they call them, the nickname they give them is freshman. Then sophomore is a second year student, junior is a third year student, and senior is for the final year student. So I see that that is an ordinal data. So it was coded this way. Let's see how they coded it. If you come here and you check, you'll see that they coded 1 to be freshman, 2 to be sophomore, 3 junior, 4 senior, like that, like that. Now, these other ones are nominal, although they are coded, but there is no perfect description. You can't say male come before female or female come before male. Since there is a gender, or since they are both equal, it's not ordinal, it is nominal, but it can still be coded. I don't know if you get the point. Athlete, whether you're an athlete or not, it doesn't matter. If there's nothing, the athlete is not bigger than non-athlete, or non-athlete is not bigger than athlete. So in that case, it's nominal, but it is coded. Please take that with you. So this is where you code them and all that. And just go through. I'm going to be sending both of these resources to the group chat, so you can just take your time to check them out and see. Then you see, notice the ones that are scale. For instance, height in inches is a scale. Remember, weight in pounds is a scale. Score on English placement test. Reading is a scale. Math is a scale, and writing is a scale. So all these are what I will want us to check, and then let's work with this, and let's see if you understand. I hope you understand what I'm trying to explain. So I think we can work with this. I think this data set is okay for us to work with, and I think you have gotten exactly how SPSS data works. So let's continue with what we have here. Now, the first thing I want us to check in this data set is smoking. Now, remember that for you to use chi-square, both of them must be what? Ordinal, or let me say nominal data. They must be scaled data. So in this case, we want to check if there's an association between gender and smoking. Now, I want you to just take a minute and think about it. Do you really think there's an association between gender and smoking? Apparently, it seems as though we have more male smokers, especially in this part of the world, than female. But as a statistician, you don't draw into conclusion. You have to confirm that using analysis. So let's check that out. So the first thing we're going to do is to go to analyze, go to descriptive, go to cross tab. This is where you perform those kind of analysis. The first thing we're going to do is to come here. Now, for us to understand this better, let's plot the graph first. Let me plot a clustered bar chart so that we can understand the concepts better. So let me say we put gender as our row, and then smoking, and let's click this clustered bar chart and let's click OK. All right, this first one is just giving us a descriptive statistics. It's telling us that 149 male smokers, 140 non-smokers, 148 non-smokers, past smokers 1324, 3137. I see that the difference is not much. So this picture is better. We have our male, we have our female, and this is for non-smokers, past smokers, and current smokers. So obviously from here we can see that the difference is not that much. But let's confirm using chi-square analysis. So analyze descriptive statistics, no cross tab. Okay, this is still what we're working with. So I'll go to statistics. I'll click on chi-square. Is that okay? Now click on continue. The under cells, although this is optional, you can just put expected and then continue. Then we don't need to show the graph again. We have seen the graph, so we can just click OK. Remember, this is our output viewer, so all our solutions are coming to our output viewer. So from here, let's check what we have. Look at the most important analysis here. Now this is if you want to solve this physically, you're going to need this graph. That's why I just ticked it. But basically, this is the most important analysis in this output, and the most important figure is this 0.2. This one I'm double clicking now. This here that is black is the most important analysis here, the most important output, and it's trying to tell us if there's a significant relationship between smoking and gender. Now, from this, is this significant or not? Based on what we've been doing, this is the p-value. It is not significant. If you say it is not significant, you are correct. Why? Because remember, our p-value, we are testing at 0.05, and this is way bigger than 0.05. So it means that we will not reject our null hypothesis. So we are accepting our null hypothesis. Remember that for this analysis, the null hypothesis is going to be that there is no what relationship, and the alternative hypothesis is going to be that there is a relationship. Remember that your alternative hypothesis is what you want to prove or what's outside the normal. So automatically we'll accept that there is no relationship, which is our null hypothesis. I hope that makes sense to us. All right. Another thing I want us to do is let's try another one. Let's try to check if the rank of the student affects whether they stay in campus or off campus. Yeah, I think. What are you thinking? In Nigeria here, most likely, I know most of the people in this class are actually students. You know that in year one, everybody did campus, then gradually people begin to shift from campus to off campus. So that is actually what's obtainable. If you run this analysis in In fact, this can be a project work. If you run it in Nigeria, I'm sure that you discover that most people, as they advance, they leave off campus. But let's check what's obtainable here. Let's start with plotting the graph. So go to descriptive, go to crosstabs, and then okay, this is not what we're dealing with now. So I'm gonna take this back. I'm gonna take this back. We're picking rank, and we're picking whether they stay off campus or not. Then let's plot our graph, and let's also, our chi-square is already ticked. Let's click OK. All right, from our graph, let's see, is there a difference? Freshman, few of them live on campus, off campus. Most of them live off campus. Sophomore is almost the same. That is the 2 students. Junior, we are seeing that most people are off campus. Gradually, off campus is increasing, and on campus is reducing. For senior, only very few people are on campus, and most people are off campus. I'm thinking that this research might be significant. What do you think? But let's check our outputs. Perfect. We can see that here our chi-square here is 0.0. This is raised to the power of minus 32. That's what's actually there. Anytime you see this 0.0, it means it's significant. But if you want to know the actual value, just hover around here and it's going to come out in green. You might not need this actually because it's almost 0. This is 6.04 times 10 to the power of minus 31. That means that it's about 31 0 before you start talking of 6 0 also. That is almost 0. So, but from this research, we see that we can conclude that our null hypothesis is going to be that there's no association or relationship between staying off campus and how long you have stayed on campus. And the alternative is going to be that there is a relationship between how long you stay on campus or your year and the other one, which is what's it now? Your year and whether you stay off campus or not. But from here, we have shown that there is actually a relationship. So we're going to reject the null hypothesis, which is as good as saying you are accepting the alternative hypothesis. So although most statisticians don't say that, but I believe it's as good as saying that. So, but the idea is that we are rejecting the null hypothesis and we are accepting the alternative hypothesis. You can take it that way. But when reporting it, you can just as well say we reject the null hypothesis, and that will do. But let's not bore ourselves with that. I believe you get the point, and that is the main thing. So the next thing is just to report your analysis, and you are good to go. Now I'm going to give us an assignment here. I'm going to send this thing to the group chat. Come up with any alternative hypothesis and null hypothesis, and come up with a research based on this data set and perform a chi-square analysis. Remember that for chi-square analysis, both of them are going to be what? Scale data. So you could check maybe whether does gender affect whether you stay on campus or off campus. Does gender affect what you use to come to school with, whether it's a car, whether it's public transport, all those kind of things. Just play around it and form your own null and alternative hypothesis, perform the research, draw your conclusion, and send it to me. So we're going to end here for now, and bye for now.